In this video, we're going to cover the extra practice problems for lesson 7.2, number 4 through 11. We are on page 204. In 4 through 11, we're going to be using this figure to find different segment lengths and different angle measures. We're going to need to use the properties of parallelograms in order to help us find these measures. So I'm just going to go ahead and keep this handy for us because we'll be referencing it a lot. All right, so for the first 4, we're going to be looking at lengths of segments. And so we're not really interested in angles. We are interested in the properties right now that deal with side lengths and diagonals because those will tell us about lengths of segments in our picture. So the first length we need to find is PO, the length of PO. This is one side of the parallelogram. So in terms of properties, I want to know what kind of properties of parallelograms deal with sides. So we know opposite sides are parallel. That doesn't really help me find lengths, but I do know that opposite sides are congruent. So to find the length of PO, if I look at the opposite side of this parallelogram, I see it has a length of 24. Well, PO is congruent to this side, so the length of PO must also be 24 units. The length of OQ. OQ is this diagonal here. So I'm interested in what is true about the diagonals of a parallelogram. I know the diagonals bisect each other. What that means is diagonal PN cuts diagonal MO into 2 congruent parts. So if MQ has a length of 14, segment OQ also has a length of 14. The length of NO, that is this side of the parallelogram. Again, this goes back to opposite sides we know are congruent. This side of the parallelogram is 26, so the length of NO should also be 26. The length of PQ, that is this diagonal here. I know since the diagonals bisect each other that the length of segment PQ must be equal in length to the length of segment QN. So PQ must also have a length of 20.7. Now we're going to start looking at angle measures in our in our parallelogram. Now, there's usually more than one right way to kind of find these angle measures and think about using different properties to find these angle measures. So just keep in mind that it's possible that you get the same answer that I do, but thinking about the problem a little bit differently. We're going to find the measure of angle PMN. That is this angle here. And so what I'm trying to figure out is what information do I have about other angles to help me find this angle measure? Well, one thing I notice is it tells me this angle, angle N, is 68 degrees. I wonder if we know anything about angles that are next to each other in a parallelogram. They tell us that consecutive angles, so one of our properties of parallelograms, is consecutive angles are supplementary. That means they add up to 180 degrees. So if angle N is 68, I know that whatever this angle measure is, it has to add with 68 to equal 180 degrees. So if I take 180 and I subtract 68, that will tell me that the measure of angle PMN, which is 112. And I'm just going to make a little note of that in my picture, that is 112 degrees. All right, let's find the measure of angle NOP. That is this angle here. Notice that one of my properties in a parallelogram is that opposite angles are congruent. So angles in a parallelogram that are opposite each other have the same measure. So angle NOP, that is opposite the angle we just found, angle PMN, which means these two angles have the same measure. Angle OPM, this angle here. Angle OPM is opposite this angle here, which I know is 68 degrees. And since opposite angles in a parallelogram are congruent, I know that angle OPM is also 68 degrees. Lastly, angle NMO. NMO. That is this angle here. I'll highlight it in a color just because I've got a lot of different symbols and things going on. So this yellow angle here, angle NMO, that is the one I'm trying to find. So one thing I notice is that this angle is part of a triangle. It's part of this triangle. I'll highlight it in yellow. Right? So one property you could use, which is an option, you could try to find this missing angle using the fact that all three angles in a triangle add up to 180. That's one option. One that kind of sticks out to me, one way to find this angle, is that we can see that because this is a parallelogram, these two sides of the parallelogram are parallel, right? Opposite sides are parallel. And if I look at this diagonal is a transversal through these parallel lines. In Chapter 3 in the first semester of geometry, we did all kinds of work with special angles created by parallel lines in a transversal. And one of those special types of angle pairs were alternate interior angles. I see that this angle here, angle NMO, that I highlighted in yellow, is an alternate interior angle with this 59-degree angle. Okay. So this angle and this angle are alternate interior angles. We know that when the lines are parallel, alternate interior angles are congruent. So if this angle is 59 degrees, the measure of angle NMO is also 59 degrees. If you use the fact that angles in a triangle add up to 180, you should have also gotten that this angle is 59 degrees.